All right, everyone. So thank you so much for joining. So today's stream is going to be a bit of like an exploration of various, like all of my favorite tools, like my favorite tools for basically doing like experiments at scale. And so a lot of this was inspired. So about like when did I write this? This is like about 3 to 8 months ago. I had like a pretty good set of practices for how to do things basically all like within shell commands. And so this essentially involved, you have all of your configs, like let's say in some form of YAML, and then you can just read a YAML file super easily. Let me zoom in a bit. You can read a YAML file super easily by just like reading this config YAML and loading it, and then you get a key value store. So that's how YAML parsers work and why YAML is such a good format. Not good, but basically here, like if you come to it, like you could have something like, well, maybe, I have some settings, like I want to have a number of epochs and I want to have a learning rate schedule and then like an amount of examples and then maybe various batch sizes that I want to go over. So instead of always changing the same script, like you sort of want to go for this approach where you put everything in configs, and then it's a lot easier for you to change stuff because you can just come in here and add whatever you want. So at the time, one part of it is like, well, you could have like a simple CLI as well. And I've sort of made the point earlier that a big part of what makes various ML people successful is that they can run experiments at scale, as in, because it's an empirical discipline, like we don't know what's the best way to do something. So what you could do is you could just run a whole bunch of stuff and then, see what works. So for example, here another one tool is like with NoHop, which lets you run long running jobs in the background, but you could also do this like by running a remote job, like let's say running something on AWS, you could also do this, or you could use something like tmux. So maybe I can talk a bit about tmux. I have the late, yeah. So I do talk about tmux here. Interesting. I already mentioned also Git LFS, which is a way of managing data sets, port forwarding. Although I'm going to show you something much simpler right now for how to deal with remote machines with VS Code. Interesting. I mean, this is pretty good actually. And then profiling, which is basically being able to look at a trace of a model. And then again, like when it comes to this idea of making stuff reproducible, a lot of it comes down to, well, you have some data and code that you're versioning. You have some way of generating this code and data, like via pipelines, and then making sure that, stuff worked or broke or whatever, you would do with something like CI. So it's also something we'll be talking about today. Conda, I don't have to convince you why this is great. Not using passwords, it's also great. Oh wow, I do talk about VS Code as well. This is kind of not bad. Good job, Past Mark. Okay, so I'm happy at the stuff Past Mark has done, so we're just going to be adding more stuff, I guess. Let me just minimize this. Okay, where was it? Here. So let's just go over like an agenda. So I'm not gonna go over this stuff. So I'm just gonna give you examples immediately, and we're sort of gonna jump right in. So let's see here. Do I have a Git repo? I do have a Git repo here, and then I set up Git LFS, right? And so what's Git LFS? Let's just take a quick look. So it stands for Git Large File System, right? So it's a way to version large files, right? And so essentially it works pretty much identically to Git, but you just need to tell it what to track, like what file formats to track. And then you add them to the Git attributes, and then once you get push, like things should just like work. And so traditionally, like what problem is this trying to solve, right? Like in Git, you're not only storing the data that you have, you're storing like the history of all the data. And so if you have a data set that's changing slightly, then you're basically going to store, let's say that data changes n times, and you're going to be storing n times the number of the size of your data set. And so then if you're doing like a git pull or something, it's just going to end up taking like hours and hours. So that's not something you want to do. So let's just do an example. Like let's say we go to the model zoo for PyTorch. I'm going to download like some model. Right, let's say, okay, AlexNet, for example. No, I don't want this smart file. All right, maybe, yeah, okay, why not? We'll use this. So copy link address. All right, so what we're gonna do is we're gonna wget this file. So this is like 200 megs, right? So if you've tried to git push something like this in the past, like you know that it takes forever. So we see here, like there's the mar file. And so what we're gonna do here is we're gonna just look at the, so they're saying, okay, we wanna say git LFS track, and then everything with this extension of PST. So in our case, it's gonna be git LFS track, and then, you know, the star is a regex. So it takes a string and then it's a regex. So anything starting with anything, and then ending with a .mar in our case, right? So now it's saying git tracking.mar. So if I go to git status, okay, great. Let's just look at the git attributes. What does it say? So, okay, so it's saying that it has the smart.mar filter. So basically it's saying do something with the mar files. So then what we're gonna do is we're gonna just git add everything. Right, so that took, and then we're gonna git commit. Committing with large data set with git LFS, right? And then I'm saying git push set stream origin main. Yeah, just I'm authorizing GitHub. Okay, so you see it's saying uploading LFS object. So it figured out that this big thing is not part of my code. And it looks like this is gonna take a while, even is it still a 200 meg file. So while this is happening in the background, like we can move on to Hydra. But you know, long story short, like generally you don't like you want to have something like a centralized database, or maybe something like an S3 bucket or whatever. But this is just really practical. Like if your workload is all in Git and you need to version data in some way to be able to audit it, like who changed it, you know, like what was missing. And this is very useful, like I think for anything like compliance related, because then you have you feel more confident that, you know, like nothing bad happened. I think it's gonna take forever. It's okay. Let's just let it do its thing. So the next thing I want to take a look at was Hydra. Right, and then so the Hydra framework is sort of similar. Remember when I said like you generally want stuff to be as much as possible in configs? Well, it's a project by Facebook that does exactly that. So what we're gonna do, I'm just gonna stop this. I'm gonna git remove. Yeah, so I guess we learned don't use git LFS, use a database. Okay, right. So let's removed it for now. So let's see. So conda env list. So I always use conda for my env management, and I'm gonna conda activate ops, and then I'm gonna install Hydra. All right, it's downloading some stuff. Great. Okay, that was fast. Perfect. Okay, so let's take a look at some examples. Like how does this thing work? Examples. Okay, so here, for example, they're saying, well, we have a config and a conf.yaml, and then we have an app. Okay. Omega conf. Okay, so we import something, and then we tell Hydra the config is in the config folder, and then the name of the config is config. So that's where the conf config part is happening. And then we have an app that takes a config dictionary and then it prints what's inside the config. Okay. So why should I use this versus a YAML file? All right, let's just look at the basic tutorial. Okay, so far it's not clear to me why I should use this versus YAML. Again, this is just my personal opinion. Oh, interesting, because then you can change the config from within the Python app. I see. Oh, I see. This is kind of interesting, actually. Okay, let's try this out. So let's say I'm going to say make dir conf, and then I'm going to cd to conf, and then I'm going to touch config.yaml. No, .yaml. All right, and then in this config.yaml, I'm gonna say, let's say I have this. I'm gonna say user mark, and then driver MySQL. Then we okay, so have some password, and then we have a separate app, which is so we're gonna go back and we're gonna say touch my app.py. Is that right? Okay, sure, yeah. Let's go to my app.py, and then we're gonna paste this, and then Hydra is not defined in Pylance. Okay, that's fine. We know it isn't. So now let's say if we say Python my app.py, what's gonna happen? Okay, absolutely nothing happened. But now if you say my app, and then we say db.user. Wait, did we set this up correctly? Yeah, we did. So db.user equals root, and then db.password equals 1234. Also nothing happens. Why is this doing nothing? Did I save? Oh, because it's an empty file. Never mind. Okay, sure. Okay, Hydra is not defined. That's a good problem. So that means we just didn't install it properly. Could be a good problem or very hard problem. Let's see. Okay, let's see. Python import Hydra. Okay, so it is working. So maybe it's just missing something like this. Okay, still not doing anything. So it is saying that this is the main, right? Oh, because it's hearing the config path is here. So if I call this conf, maybe this will work. Okay, also didn't work. Now let's say I remove this. Okay, Hydra is not defined. Okay, cool. That's a bit better. Yeah, I figured too. Even though they're not mentioned in the tutorial, which is surprising. Oh, import. Okay, there they are. Okay, yeah, sorry. Import Hydra, this. Okay, then this. Okay, still no? Okay, I'm really dumb. Okay, there we are. So it did something, though. It feels like it created some stuff somewhere. Did it? Yeah, so it logged the configs. Okay, that's interesting. So okay, so you see, so it wrote the version of the config, and then it said these were the configs. So this is what we had in the config. No, so this is what we created, right? So we said the driver we didn't change, the user we changed, and then the password we changed. And then here, what is it saying? Configuration group. So I'm assuming though, like long story short, I think what this is doing is then keeping track of all of the configs that historically happened. So now let's say if I say db user is equal to mark, and then db.password is equal to 420 LMAO, what happens then? So yeah, so then there's another day. Oh, this is great actually. This is really neat. Okay, so basically think of it as versioning like the archive of all of the configs that you've ever had for your program. So basically then you can come back and actually get to run them. So this is really useful, I think, when it comes to when we're actually going to be talking about something like weights and biases. But I mean, yeah, I'm definitely a fan. I think I'm going to start using this more often. Okay, something else I want to show you is Docker, right? So one thing I really like about Docker, so let's see, I think it was Docker run hello world. I forget what this error was. Okay. So we'll be talking about Docker and VS Code tricks next. So lots of cool tricks here. I've seen this error before. Yeah, it's the sudo group. It's like it needs a user called Docker. Okay, group header exists. Okay, great. So then I think it was just the last one because I've had to do this many times on like just AWS machines. This very command. Okay, so then if I say docker run and then hello world. All right, so look at what happened. So right now what we did is we ran a container, so an image is basically a blueprint. And then you want to instantiate that blueprint. So if you've ever done something like with anything with Linux, you may have noticed like you have these things called bash RCs, right? So let me just make this a bit bigger. And so what a bash RC does is it determines like at startup time, what are the list of things that you're going to do, right? And then so in the case of a container, you want that list to be fixed because you can eventually share the same container with someone else. So you can share the code and the state of something with someone and not just the code, which is like, let's say what you're doing with GitHub, like you're only sharing code, you're not sharing state. So Docker files look very similar, and I'm just going to show you, I guess, like some syntax for it. So I'm going to say like this is a Docker file. So you notice it opened up the Docker extension for VS Code, and this is part of the tricks I want to show you. But let's go back here to the Docker file. So let's see, sample Docker file. And we can go over this code a bit. So yeah. So what is this doing? So first off, we're saying, well, we want this here. So first off, what we're saying is we want to start from a base image called Node 12 Alpine. So think of this like the AMIs on Linux, on AWS, sorry, which is you are basically getting an image that has some libraries pre-installed. Once you get this library, you're basically just going to run a command. So anything with run is running it. You're going to have a working directory called app. So think of it as this is saying make dir and then cd dir, right? Then you're going to copy the current directory to the remote directory. So you're basically copying file systems. Then you're going to run yarn install, and then you're going to run the command node source.js. And the important point here is like, what's the difference between command and run? Is command is the last thing that you want to run. It's sort of like my program starts here, whereas everything else here is just basically creating some state. So now what we're going to do is, and this is kind of the nice thing about this extension, is I don't actually have to show you too many. Why is this failing to connect? What's happening? Work. Okay, that's all right. Like, let's say, so here, so now in test, what I'm going to say is docker build -t. So -t is just basically give it a tag. So I'm going to give it a name, and then I'm going to say dot because the current directory has a Docker file. So it's going to do Docker file cannot be empty because it's indeed empty. So I mean, maybe instead of this, like instead of doing node stuff, I'm just going to get rid of this, and I'm just going to run the command and just say I'm going to run Python. And you know, like pretty much that's it. Let's see what this does. Right, and then let's go back here. So now what I'm going to say is docker build -t. Let's say I'm going to call my container meta. So this is dot is just saying like, look at the current directory. So it's installing a bunch of stuff. In this case, it's doing it like, actually the interesting thing about building Docker images is that they happen step by step. So each of these is a step. And if you change only this last part, like it's not going to recompile everything. So for example, let's say here, I'm going to change this to 1+1, for example. So check this out. So you see how it immediately, like this went really fast and then it just went. So they're very modular in that sense, especially like you could build a container. Like put this container on a container registry, and then someone else could get this new container. So I'm just going to build it one more time. Right, and then if you go Docker images, you're going to notice that we have like a bunch of containers like all set up here. I'm surprised, why does this not work in VS Code? Because I wanted to show you something. I was going to talk about how great VS Code is, but it looks like they're going to disappoint me. But yeah, I mean, regardless, so then what you want to do is say like docker run, and I believe you just give it this image ID, so docker run meta. Right, so now it's saying user bin Python can't find main function and module. So it works actually, because it's saying like, well, didn't see any code. So maybe we can make this a bit more interesting, right? So how about we do this? So we're gonna create a Python file, and then we're gonna call it like, I don't know, like hello.py. All right, and then so what we're gonna do in this file is we're gonna say if name equals to main, right? So you start, and then we're going to say print hello world. Right, so then the next thing we're going to do is we're going to say we're going to copy hello.py to the machine. So this is the name of like basically here. So I'm going to do this. So we're going to copy the whole directory, and then we're going to run Python, and then we're going to give it hello.py as an argument. So let's see if this works. So we need to rebuild it. So now that it's doing the copy, that's a bit more expensive. It needs to copy a whole bunch of stuff. Okay, and then we can say docker run why is it doing yarn and stuff? Where was the removing intermediate successfully built this? Docker build, docker. Something weird's going on. So let's just quickly check. So if we go docker ps, okay, there's no container being currently set up. So then we look at what images are available. We look at meta, which was created 37 seconds ago. So that's the one we want. So we're going to say docker build. Sorry, docker run. It's not taking the right Docker file. Let's see. So I'm going to say, let's just build it again. So docker build -t, docker build -t final. Of course, it's never final. Okay, so we built final, and then we're going to say docker run final. Right, and this printed hello world. So this worked. Right, and so the idea here is now like, well, if you want to publish this on a registry, I'm going to show you how to do this. So we can actually share this on Docker Hub. So let me just get my credentials real quick. So smart, right? Okay, so my Docker ID is my name. Then this is a password. All right. So something's happening, right? So now you see this. And so now the question is, can we actually publish this thing? So why is this not working? Okay, that's fine. Let's just quickly look at a command. So share to Docker Hub container. Okay, so we're gonna say docker push, docker getting started. So basically I'm gonna say docker push, and then I believe it should be with my name, and then Mark Serafim, and then final. An image does not exist with the tag final. So if I say, let's say, if I just say final, right? So requested access is denied. Okay, why? Docker image ls. Okay, so this is the image we're pushing. It's going to be 520. Like you notice, like even though it's on 520 megs, and why is that, right? Like, is the data still here? It's not, right? And this is something I've noticed quite a bit as well, where these containers can get very large. But, again, they make your life easy, and, make sure to get a nice internet connection. Okay, so log into Docker Hub. So we're gonna say this. So Docker login dash your username. Docker login dash Max Serufim. And I believe we had the password here. Okay, cool. So we're logged in, but now we have my password unencrypted in the config JSON. So it's gonna be fun when I push this to Git. That's okay. So once we have that, we need to tag it. So we're going to say docker tag and final. And then we're going to give it my name on Docker Hub. So Maksarufim final. All right. And then we're going to say docker push Maksarufim final. All right. It feels like this is working. Again, feels very slow. But again, when you're thinking about like, well, you're debugging something with someone and it's like a big mess, I think there's like two ways to do it actually at this point. I think sharing a container with someone is a great idea. And another trick I really like is shared terminals. So like, let me talk to you about tmate for a second. Tmate install, because I use this on my Mac quite a bit. Okay, so I'm just going to get this thing and I'm going to paste it here. This thing's insane, by the way. Like, I mean, it's kind of a security risk as well. So here, so now I'm saying a tmate and it's doing some crazy stuff. Am I going to get hacked? Probably. Run SSH keygen, SSH keygen. Sure. No passphrase. No passphrase again. Okay, great. So now what I'm going to say is I'm going to say tmate. Okay, so there's an SSH session here. So let's see. So it's a race for if you guys can hack me before I can hack you. Tmate. Okay, so let me close the terminal again. Start from scratch. All right, so you see it gave me this thing here. Why can't I copy this? Why is this so hard? Okay, so now let's say I go here. I'm logged into the same machine. So let's say if I, notice this. So I mean, if you go to this URL as well, like you'll be able to. But like again, this is a really trick. Like whenever you're thinking about anything that involves challenges with reproducing stuff, this is, I don't know if you have heard of this command. It's like if you have many prompts where you have to say yes a lot. You can type yes and this like types yes over and over again. So yeah, I mean, like I said, containers are, I think, containers are one way of doing this, but like a shared terminal session is as well. So let's see the container here. Okay, so it's still loading because it's going to be loading a lot of stuff. So yeah, make sure you're using a great internet connection. But that's pretty much it, right? So Docker files, remember, they're kind of like bash RCs. Like the commands all sort of make sense. You build in, like, given a container, which is a blueprint, you build an image, then you do stuff with this image, and then you can deploy it. And so you can also, like, and it's not shown here, but in VS Code, you can actually inspect. Maybe let me do this. Because I'm surprised it's not working right now. Why is it failing to connect? Is Docker running? Yes, it is. I mean, so we did do this, but you know, whatever. This when I tried this on AWS, it worked just fine. But regardless, like what you could do is you could also inspect the file system. So let's say we're doing something like Docker around the world. I think it's like .it or something. But regardless, like you can actually set up a shell and do stuff with it, but that's generally not what you want to do because, again, like you want everything to sort of like you do like you set things up once and then it just works. And then with stuff like Docker Swarm or Kubernetes, like you can actually scale it. So let's say you want to create like 1,000 of these instances without necessarily knowing on which OS they are or whatever. Then you know it works great. The main thing to keep in mind with containers is that they do share the underlying file system. And so if you are doing stuff where like you can essentially when you're running a Docker run, like let's say hello world, you can also give it a volume, so you can tell it like, okay, like take my current directory and load it to the current directory. You can also expose certain ports, so you can say, okay, take port 8080 and then expose it on port 8080. If you're doing a lot of this stuff, containers get very, very slow. And you want to think of it as like this isolated stateless thing that you're running. Like if you're doing something like databases or something, I don't think is generally like the best the best idea to work with containers. So yeah, I mean, moving on the list, we're actually going faster than I suspected. Yeah, so I recently like saw Gradio and I really liked it. So I just want to quickly show it to you. I guess I had an extra. So it's basically a UI library in Python. So you can write these like really simple user experiences and then get them working like from within your terminal. So you don't need any. So in the past, like what I've basically done is something like you know, like I had my previous session was about this actually, but it's sort of setting up a web app using something like jQuery and Flask. But you know, after using Grade, I think this is actually what I'm going to be using for my project. So let me just show you how it works. So I'm going to conda activate ops, and then I'm going to pip install Gradio. So let's see, it's installing matplotlib, it's installing Flask below the image processing library, NumPy, SciPy. So you can sort of get a sense of like it's really trying to be the like ML UI library, and I think it does a really good job at that. I'm definitely a fan. And then, so while it's doing all of this, let's see. So we're going to call this what? App.py. And then it's going to be this. And then I'm going to say Python app.py. Okay, so it's doing something. Let's take a look. Yeah, okay, so let's say if I say Mark, it's going to say hello, Mark. All right, so how does this work exactly? So we're really creating a function, and this interface is basically going to map inputs to outputs using an interface, and then you launch this iFace. That's pretty much it. I also noticed I have this thing called share equals to true. Let's see what that does. I would suspect they would tell me you better pay up. What do you mean I got unexpected inputs? You told me share. What was it again? Yeah, I have actually heard of Streamlit. I'm also a big fan. I think like what I liked about Grade is that like I just like looked at it and it made sense to me. So, but there's no like real reason why I would recommend it over like one over the other. I think they seem fairly similar to me. So let's do this actually. Yeah. So I was just putting it in the wrong function. So I would suspect here that, okay, so they're telling me you could share it locally. So let's see, does this work? So if I put this link in chat. Okay, there's no chat here. Never mind. Let's go to myself. Look at this guy. Okay, we have 4 people in chat. Well, folks, if you have any questions, feel free to let me know. Okay, so it looks like this sorta works. So I think this is good. Yeah, and then it looks like if you want it to be permanent, I think you would need to pay. And I saw like it's like $7 a month or something. But there's actually more interesting examples that I noticed here. So let's take a look at like something a bit more complicated. Let's see what this looks like. So to create a public link, set share equals to true and launch. Okay, sure. So let's take a look at this thing. Upload an image. Can I take a screenshot? How do I? Okay, I'll print the screen. Let's see what happens. So print screen. Okay, no. What do we want? Like, let's say a dog. Okay, this dog is cute. Okay, so we're gonna save this image. Where were we? Okay, so we submit this dog and then we can turn it to sepia, for example. So looking at this example, you know, you'd have like, okay, well, we have this sepia filter and it takes an image and then it returns another image. So so the output here in this case is an image. And the input is also an image that has to be of size 200 by 200. And then we're running the sepia function on it. And so if you're wondering like, well, how does this change for a machine learning model, is that like you're going to have something like class neural network, you know, from neural network.module, right? And then you're going to have some function that says forward, and then you're going to say return, you know, so let's say we're going to have something simple, x equals, you know, fully connected something. I forget what the name is. So, and then 200, and then return, let's say layer 1, and then you want to return layer 1 on x, something like this. So let's say this is your function, then you would basically come in and put your forward function here. So again, like a neural network is just a function from an input to an output space. And this is why I think I really like Gradio's like abstractions, and that like it makes this relationship really obvious in the UI. And I'm a big fan. Like I think I really love the perma hosting as well feature. I think it's really neat. Like if you want to share quickly a model or sanity check it or something with someone. So definitely something to think about, like where you want stuff to be more visual. I just remembered actually, so I wanted to set up like an AWS machine and then show you how to SSH into it with the file system here. But instead, I think I could do it with tmate because it proves the point as well. So let's say I'm in tmate here, and then, okay, I have this URL right here, right? And so now, if I go to VS Code and I type in SSH to this URL, and then I want to say I want to add it to this config. And so if we look at here, like, let's take a look at the SSH config. So we have this host name, and then we have a user called this, right? And then if I say connect host to current window, you can see here, I think my face is blocking it, but we're connecting to the host. Here, I'll remove my face for a sec. Okay, it did time that. This usually works though. Maybe to prove the point, let's do Google Cloud. Is there a free VM I can get? Let's see. Your free trial is over, but I can always sign up for a full account. Okay, let me sign up. Okay, do I have any... Am I even running anything here? So let's say you go to Compute Engine. All right. So this is going to be a bit like, I wonder if there's an easier way to show you this, because I don't want to sit and do billing and stuff right now. Long story short, like all of these cloud providers will generally then give you a URL. They'll say like, okay, you can SSH into this thing. And once you do, you can basically come in here. You can just like put it in. So if you say Command Shift P, can you start tmate on collab? That is a good point, actually. That would be interesting. Let's try that, actually. Let's see. That's a good suggestion. Thank you. It's nice to see you, I think, on channel Caffeine Counter. So let me know if this is relevant to you, or if there's anything you want to learn about. Yeah, I think I can do that. If tmate works, then we can do it. So tmate install on Google Colab. Let's see. So hopefully, what OS does Google Colab run? Does this work? Okay, looks like this is working. So it uses, okay, no, it doesn't look like it's working. Failing back to front end, is this working? So if I say tmate. Okay, so I'm gonna say SSH. I feel like we're doing something we're not supposed to. Okay, it's complaining about not finding keys. Okay. Stop. Okay, enter each file, save the key in. Just, yes, this works fine. What's happening? Okay. It's possible to answer, and I'm usually watching your older VODs because I can't seem to catch your streams live. Oh, that's awesome. That's good to have you on. So basically, answer terminal prompts in Google Colab. How does this work? Oh, I see. It will start a bash session. Okay, that's probably the best thing. So let's see, bash. Okay, something weird's going on. Like I would suspect there's something bizarre happening here, because I think generally when it comes to forwarding Google Colab ports, they're like a bit stingier with it. And it looks like they want you to subscribe to Google Colab Pro to get the full shell and do whatever you want. So yeah, I apologize. I don't think this is gonna work. But at least like for an AWS or any GCP machine, this would work fine. Or maybe fuck it, we'll just do let's just do GCP. Might as well. All right, so I'll go to the console, and then we want from the compute engine a VM instance. Okay, create an instance. Is there a free instance that they give? It's really slow, by the way. Come on, Google. This is the smallest thing we can get. Yeah, it's on a micro machine. Just 1 gigabyte. Okay, sure, we'll just create an instance for now. Okay, so while this is creating, I think I need to set up Google Cloud CLI. Okay, so we do this. And then we tar xvf Google Cloud SDK. So a whole bunch of stuff. CD Google Cloud SDK. And then we're gonna install okay, do you want to help improve Google? No, don't monitor me, please. Sure. Enter, yeah, sure. And then gcloud init. Okay, start a new shell. Gcloud init. Okay, great. So this is working. Would you like to log in? Yes. Doing a surprising amount of stuff from scratch today. I'm surprised at the progress we're making. Okay, we're authenticated. Pick Google project to use. What project am I using? What's a project? TensorFlow tutorial. Okay, sure. So it's 5. No. All right, so now we have this VM running. And then what you can do is this. So you come in here and you say I want to SSH into it. And then you would run this command. Okay, so it's basically setting things up. Yo, hey Mutlaq. How's it going? Yeah, running Ubuntu this time. It's like, because we're actually doing like lots of dev stuff, so it'll just be a pain in the ass. Okay, great. So, and then I think, what was the command? There was one that's like gcloud config ssh. Yeah, gcloud compute config ssh, right? Okay, sorry, this was very long-winded, but the reason we did all of this is because now if I say gcloud compute config ssh, it should give me a machine name now that I can SSH into. Come on. Come on. Why is this so slow? Insufficient authentication scopes. What do you mean? I did authenticate. Well, you know, like what it's gonna look like is this. Like, you know, we're gonna eventually just come in. So we're transferring SSH keys to the VM. And then we're gonna be able to load the whole file system in VS Code. So it looks like it's like locally run. Very, very, very convenient. So I'd highly recommend it. Yeah, so it'll look basically like this at the very bottom. And then I wonder why is this not working? gcloud compute config ssh VS Code. Very surprised this doesn't work. Could not fetch resource. I wonder if it's just like the machine's so tiny that I don't know, like a gig of RAM. That's like I don't know, like a smartwatch at this point. It's probably not enough too. It's much slower, by the way, running here than on the dev servers I've been using. Yeah, I have no idea to debug this right now. So let me just kill this machine. And hopefully there's nothing surprising going on here. I don't get a surprise $1,000 bill. I've had more than that as a mistake in I think like 5,000 or something. Never again. Is my card even here? Okay, great. This is perfect. So let's see what was on the rest of our agenda at this point. So we still had open folder, dev, and then test. Okay. So we did Gradio. Yeah, so I showed you this in the very beginning. So we still have left weights and biases, GitHub actions, and testing. Okay, perfect. Let's say we say git status here. And I'm gonna git remove conf myapp.py outputs. Fuck it. I'm gonna remove everything. So git remove not recursive, all these boys. Move app.py conf hello my app. What do you mean it doesn't match anything? Oh, to remove recursive outputs. Okay, remove recursive conf. What else? Remove recursive flagged. So we have something a bit more reasonable, right? All right. So now let's say we say git add agenda, git commit agenda, and then you say git push, for example. Git push set upstream origin main. Why is it still doing Git LFS though? Oh, I see. Because we still, I think we need to vim the Git attributes, and then just get rid of this whole thing. Add git attributes, git commit.m, git LFS removal, git push origin master. Why does it keep showing me that? So git, dear God. Okay, so where was it? Git push set upstream. Yeah, git push set upstream origin main. Okay, it's frustrating that it's still doing the git LFS stuff. So let's just forget about this. I'm going to create a new directory, make dir test2. And then I'm going to go to GitHub. And I'm going to create a new repo. So by the way, I'm explaining how CI works now. So I'm going to go here and I'm going to say new repo. And then CI test. Okay, perfect. So now we're just gonna run all of this. And then cd test2. Okay, great. So it looks like this worked. What about that? Someone ringing on my door. Okay, so right. So now we have this repo called CI test, and so the first thing we're gonna do is I want to show you this GitHub action that made it very obvious for me. So git CI test. So if you ever looked at those like libraries and they have like a little green circle and it's like, oh, everything looks good. GitHub actions, Python. The LFS was never pushed, but you committed it. But you didn't commit the removal of that model file after you commit that change. It should fix it. Oh, I see. Got it. Okay, that makes sense. So here, what was it? Building and testing with Python. So remember, like again, you notice like here it's using YAML again. And it's also, it feels a bit like Docker, right? In the sense that, you know, it's like, oh, look, it's this image and then there's these actions and maybe there's like some, here, for example, we're saying like get the matrix Python version and then set up this action, which is setting up something with Python. And then we're going to run some commands and then we're going to lint them, right? So let's do this. So first step is we're going to say touch dot github. So make dir dot github and cd dot. Thank you. And then we're going to say touch workflow. And then where was it? So we'll say vim workflow. It's got a bit confusing where we are. Okay, so we have this workflow. Okay, so remember, so what is this doing, right? Like if you look at it, it's installing like PyTest, which is a testing framework, Flake, which is a source code quality framework, and then it's going to run PyTest, right? So let's have a test then, right? So let's say I'm going to say test .py, so Python test. PyTest example. So yeah, we're just gonna literally pick their first example. And again, like in the case of machine learning, like where does this become interesting is like, let's say you say something like define model regression. And then you basically say something like model equals get model from some, you know, get the latest version of the model. And then you would say model.forward on, you know, so you would have a bunch of regression examples. And this is a list. And then you would have regression output. And then this is a list. And then what you want to make sure is you want to assert that model.forward, like basically for example and output in zip of regression examples regression output. Assert that model forward on regression example equal to regression output. So the example I like to give here is sort of stuff I did when I was at Microsoft, for example, where it's very easy to come up with a, let me see, let's zoom in. Okay, yeah. So, you know, like when we think of errors generally in ML, like it's like, sure, you could have like 99% accuracy, but let's say it's something like traveling, right? Like where you're parsing someone's travel information and you have millions of users. So then you're going to have like thousands or tens of thousands of people that, you know, for any given email, you're going to fuck up the way their travel information is generated. And the cost of that is very high because if someone misses their flight because of your model, like that's thousands of dollars that they've lost in money. Maybe there's like a big deal, like they really needed to travel, maybe lost a job, a loss of a loved one or something. And so it's not enough to just say, oh, like my accuracy is good, let's go. I think that's where having a regression set is really a big deal. And this is how you could integrate it with something like with a test framework. So we're not going to do that right now, but that's maybe potentially like an interesting idea for a future video. We're just going to test this thing. So we're just going to test this.py, right? And then, right? So this is pretty much our workflow. So let's go to the terminal. And now we have git status, and then we're going to git add .github. And no, why is this here? So this should be here. Okay, so git status. Git add .github workflow, and then git add test.py. Did commit added CI test, and then git push. So let's see what that does. This worked. So if we go to GitHub now, okay, so we're gonna say set up this workflow, publish Python package. Oh, interesting. So you could say like, oh, I want to set up publishing to PyPy, right? Because you want to make some changes, automatically pull them from main, or you just want to test the application. So in this case, this is the test workflow. And yeah, look, this is fascinating, right? So they're really saying like, okay, it's the exact same thing. We're pulling it from latest. So we have github.workflows with Python. Oh, I forgot about I just called the workflow YAML. Okay, that's probably not gonna work. Okay, this is great. This is really nice, actually. So let's try this out. So we have the workflow. Okay, so this got queued. So hopefully this test should pass because, or it shouldn't pass, right? Because 4 shouldn't be equal to 5. So this should hopefully fail in a bit. So what's left? So I think, let's go back to our agenda, our handy agenda. So we talked about GitHub Actions. Maybe Airflow I'll briefly, I'm not going to run an example, but I'll just quickly show it to you, then we can end off with weights and biases. Is this complicated to install? I wonder. It's just pip. It is not just pip. Okay. So I'm sure the Docker instructions are simpler. Okay, it's a bit more complicated, it looks like, because there's many components to it. But there's an example I liked. Let me show you the tutorial. So the way this essentially works is we're going to set up a DAG, as in we're going to set up a bunch of commands that need to run with some dependencies. So that's a DAG, like, because ultimately things need to end. You can't have the dependencies be circular. So for example, here is we're going to have, like, let's say we're going to have 3 nodes in this DAG, T1, T2, and T3. And in this example, we're then saying that T1 feeds as an input to T2 and T3. So the parent of T2 and T3 is T1, but that these two things are independent. And so in this case, we're just doing sleep commands. But, you can think of this as like, well, you could just give it a Python file. So let's go. I'm sure they have it here somewhere. Yeah, so here, for example, okay, you set up like Airflow. It's going to create some metadata for you. And then you set up your DAG, and your DAG has a bunch of commands, like Python files. So then you could say something like pre-process data, and then run model, and then deploy model. So each of these things could be part of your DAG, or detect data drift. Like that's another DAG that would then trigger something else. And then, so again, these are all things to think about, because I think a lot of ML has become really commoditized, and these are sort of, I think, the key tools that are helping people actually build useful stuff with machine learning nowadays. So let's go back to our test. So it failed. Why did it fail? What does this mean? No tests run. Oh, I see. Okay. Okay, so they need to be called test something. Do I have files called test something? Oh yeah, I mean it is called test something, and then where is it? So where is it looking for this? Like, is it maybe perhaps like its own folder or something? So what happens if I run pytest here, for example? Maybe that's simpler. Install Python pytest. All right, stuff is happening. Pytest. Okay, so it is actually not finding anything. So how come? And it is in the directory, right? It is. So pytest won't find my test. So by convention, it searches for test classes that are called test class without an init method. Okay, so if I say class, test class, all right, so define this. Okay, so then I can say this. And then I'm guessing this needs self as well. Okay, yeah, so now we're good, I think. So let's try this again. So first, let's just say pytest. Okay, also didn't find any tests. I wonder how this works. Am I missing something? Running pytest. Because I've only ever added tests to like mature code bases, never added my own to a small project. Of test underscore sample.y. So I mean, let's say if I call it test underscore sample, will that work? Probably not, right? Okay, guys, like, yo, like, this is weird, right? Like, why would test work but not pytest work? Let's give it another test. So let's say define test answer to self, and then this asserts that self.inc4 is equal to 5. Right? So now if you say pytest, it said one failed, one passed. So then if we say git status, you know, let's remove this thing now. Okay, so these naming conventions screw with me sometimes. Git status, I'll say git add test.py, git commit.m test, and then git push. So git pull. There's no conflict, so I'm just gonna do this, and say git push. Okay, now what happens? Okay, so if we go back to actions, yeah, so now there was the merge. So this should pass. Okay. So I think the last thing I want to talk about today is weights and biases. So weights and biases is install dependencies. See, that's what I like about it. It shows you step by step, like this is where it failed, this is where it worked. And it's really very similar to Docker, and I'm surprised that why is it doing the same shit again? Home runner CI test. Okay, I think it probably comes down to where it's looking for the tests, it feels like. So I think that's something we can solve with a bit more Googling. But at least you can see like the main idea. It's like you have this test harness and then it does something remotely and also validates them. And you could maybe like block the merge, for example, on something, or you could upload to PyPy or upload to Conda or update a Docker image. So all of these things, like you can sort of chain your code to state to what people are using, which I think is very useful, specifically for this use case around regressions. So I think the last thing I want to talk about is weights and biases. So let's see what they do. You can find your API key here. Have I used this? I haven't used it recently. Let's see, what are they going to give me as an API key? So weights and biases is sort of an artifact tracking library. And so it keeps track of everything you've done with your models. So what we're going to do is just going to get an idea of, okay, we'll say appending key, enter your choice. Let's say sample project, 1db sample project, and then it also added the train.py for me. It did, yeah. Okay, so there's a settings files and it's ignoring it, and then it's create a project called sample. So in your training script, 1db, and then python train.py. Okay. So it looks like we need to create a train.py. And so in this train.py, we're going to say this. So we're just saying, dear 1db, please keep track of stuff for me. So I'm just going to say import 1db. And then I'm going to say 1db.init project equals sample project. Let's see, 1db sample. Let's see, training file PyTorch. So I just want a like really beginner thing we could do. Where's training? Where's the whole thing? I don't want this sort of copy a million things kind of thing. So where is there training here happen? Step, optimize. So there's a forward and then a class and then model state dict. Okay, let's try something like this. I know it's not training, but I think it'll do for now. Let's say I do this. And then I want to say python train.py. Okay, so I'm going to say pip install probably torch and torch vision. Import torch, import torch vision. Then say pip install torch and torch vision. It'll take a while. We're downloading the CPU version by default, but this works fine. You know, I do have a GPU configured here, but we don't really need it. So let's see what this does and if it's useful. Ugh. Entirely, this is longer stream than I expected. Okay. Come on, torch. It's like big boy. It always hangs, by the way, for me, right at the last second. Almost always. Does anyone have a good answer, actually? I wonder if we're like downloading long-running pip files without crashing. Like sort of something that's robust to intermittent internet connections. So from torch import, no, not torch. No. Oh, for fuck's sake, let me see. Torch, hello world. Does someone have a full example I can run? Okay, yes. Thank you. Okay. Python, train.py. Okay, so notice how every run here was stored. It has the files, which had the conda environment. It had the config YAML telling me the framework, was it in Jupyter, what was the Python version. It also has the full output, so basically everything I printed to my console. It also has requirements.txt. It has some metadata around like which, interesting, yeah, like what was the git commit, what was the name of the person, from which directory did they do it. So again, like the idea here is that I think they have all sorts of stuff you can do to create plots and stuff. But at the very least, you can just do this and then not lose track of your runs. So then if you click here, these should be synced on the cloud, I guess. And then what are my available system? Okay, so it's just like a single data point, I guess. It's showing me my logs, my files. And so I can share them with people, for example. So again, this is just yet another way of making stuff reproducible. Like either you share your actual terminal, or you share the configs that you used, or you share the actual machine. Like you basically ship someone your laptop in as a container. So there are various ways of achieving this goal. I mean, yeah, this is great. I enjoyed this. So let's just quickly iterate before we shut it down for today. So we go to ls, and then ls cd test, and then code agenda. Right, so we talked about Git LFS, which is a way to store large data sets in Git. Even though it's not necessarily the fastest way to sync stuff, it's very useful if you're already used to Git. We talked about Hydra, which lets you keep track of all the configs you use to manage your experiments. So generally having stuff in YAML files is very helpful. We talked about Docker, where Docker files were like bash RCs, where you can basically say a set of instructions for how to set up a machine and then put it on the Docker hub so that other people can use it. We talked about how VS Code can let you inspect Docker containers, how it can you can use it to SSH into remote machines like on GCP or AWS. We talked about Gradio. It's not great, it's Gradio, which is a really simple way to create user interfaces within Python. So it's very useful for ML because you can set input and output functions, and that's really what a forward function is. We talked about weights and biases, where all we did was set up like a 1db.init, and it kept track of our environments, our requirements, our code, and everything that was printed to console automatically, puts them in separate folders, and then makes them really easily shareable on their service. We talked about GitHub Actions and how we can basically set up a simple testing workflow where you can just make sure that it passes the test. We talked about Apache Airflow, which is a pipeline management library for ML that helps you set up your dependencies, like script dependencies as a DAG, where basically your parents are what needs to be run before you. And we generally overviewed a lot of the tips and tricks I mentioned for how I did MLOps about a year ago. But at this point, I'm starting to use tools a lot more, even though I know there's a lot of them. The fact that they have been getting a lot easier and people use them makes it easier for me to work with them. Oh yeah, and we also talked about tmate, so sharing your terminal session to work with other people. And we talked about how to do the same thing with weights and biases. So yeah, I mean, this was really fun for me. I hope you enjoyed it. If you have any suggestions for other kinds of videos you'd like me to work on, feel free to let me know. And thank you so much for watching, everyone. I really appreciate it.